Kita bertemu lagi pada pagi ini dalam live classroom at Edidik. Alhamdulillah, pada pagi ini kita bawakan chemistry form 4 KSSM. Jadi kepada semua murid atau semua guru yang menonton, kami di Edidik Negeri Perak untuk Edidik merakamkan ucapan ribuan terima kasih kepada yang bersama-sama kami. InsyaAllah kami akan cuba bawakan kepada semua murid, terutamanya dalam tempoh PKP ini, khususnya dalam norma baru, norma baru pendidikan. Kita bawakan pengajaran secara atas talian. Jadi sebelum kita teruskan lebih lanjut lagi, diharap kepada semua untuk sama-sama subscribe channel YouTube Edidik Malaysia. Mudah-mudahan banyak lagi perkongsian kami pada selepas ini dapat memberi manfaat kepada bersama. Jadi kita pada pagi ini kita akan bersama dengan Puan Komathy dari SMK Buntong, Ipoh Perak. Jadi tanpa melengahkan masa, saya jemput dan saya persilakan Puan Komathy untuk meneruskan sesi ini. Silakan cikgu.
Okay, thank you, sir. Sir, can you hear me?
Yes, yeah, we hear you.
Okay. Good morning. Good morning, everyone. So my name is Komathy Veerasinghan from SMK Buntong. I'm a chemistry teacher. So today I'm here to share with you all on chapter 4, form 4 chemistry. So for your chapter 6, we'll be learning about acid, base, and salt. So before I start my online class today, I would like to inform you all to prepare certain things for us to go through our online classroom today. First, please get prepared with your textbook, form 4 chemistry. Secondly, please get a piece of paper and a writing tool with you, because in between of my slides, in my presentation, there's some activities for you to carry out. Okay, are you ready? Shall we start now? Okay, in this chapter, for information, there are 11 subtopics. So for today's lesson, I'm going to focus on 2 subtopics. That is, the role of water in showing acidic and alkaline properties. Secondly, we're going to learn on strength of acid and alkalis. The learning standard for our lesson today, at the end of the lesson, you'll be able to define acid and alkali. Second, state the meaning of basicity of an acid. Third, explain the role of water in showing acidic and alkaline properties. Fourth, define strong acid, weak acid, strong alkali, and weak alkali. And finally, you'll be explain the strength of acid and alkali based on its degree of dissociation in water. Okay, what is acid? I'm very sure that you have learned about acid while you are in your lower secondary and even in your primary, right? So usually when I ask what is acid, what the first thing comes to your mind? Oh, acid is corrosive. Acid is something which is less than pH value 7, right? So now students, as a chemistry students, we have to be very precisely define our terms. So acid, based on Arrhenius theory, they have defined it that chemical substance that ionizes in water to produce hydrogen ion. Okay, what does this mean? Let's say I have a lump of a substance X, then I put it inside the water and I find it that this substance ionizes hydrogen ion. Hence, this substance can be classified as acid. So let's look closer on this diagram. Okay, over here, as you can see, HCl gas. What is HCl plus? Hydrogen chloride gas, right? Okay, when this hydrogen chloride gas in the tongue, then this will exist in the form of molecules. Can you see the structure? This hydrogen chloride will exist in a form of molecules. But when the moment it dissolves in water, what happens is these hydrogen chloride molecules will ionize their respective ions, which is chloride ions and hydrogen ions will be produced. Hence, due to the production of hydrogen ion in water, when it ionizes, hence we can call this substance as acid. Now, as you can see in the yellow box here, this is called ionization equation. Now, HCl is the chemical formula of hydrogen chloride molecules. When this hydrogen chloride molecules dissolves and ionizes in water, it produces hydrogen ion, which is H plus, and chloride ion, which is Cl negative. Now, I would like to share with you one animation on this production of ions. Okay, as you can see here, okay, so when nitric acid, here I'm showing the animation for nitric acid dissolves in water. Look closely on this animation. When nitric acid dissolves in water, look at the reaction that happens. Okay, what you observe here, I replay back. Look closely on the reaction. Okay, when nitric acid dissolves in water, the hydrogen ion, which is ionizes by the nitric acid molecules. Okay, so the hydrogen ion will react with the water molecules. They form this structure. What is this structure called as? What's the name of this compound? Okay, as I show you the animation just now, the hydrogen ion, do you think it will remain in the aqueous solution? What happens to it? When the hydrogen ion from the acid molecules ionizes, it will form an hydrogen bond with the water molecules. And this is, you have already learned in chapter 5, hydrogen bond. I would like to recall back what you have learned in chapter 5 earlier on hydrogen bond. When the hydrogen ion from the acid molecules, they attracted to the water molecules, they will be forming an hydrogen bond. Hence, it will result in the formation of hydrozonium ion. Actually, this is the real story of acid. To cut the story short, what we say is we don't elaborate up to hydrozonium ion. The moment there's a hydrogen ion formed in the water, then automatically it's going to form the hydrogen bond with the water molecules. And it will result in the formation of hydrogen ion. So that's where we define the acid as a chemical substance that ionizes in water and produces the hydrogen ion. We don't talk about hydrozonium ion because it's understood the moment there's a hydrogen ion, it's going to result in the formation of hydrozonium ion. So class, for definition of acid, what you have to emphasize here is there are two keywords you have to bear in your mind. Chemical substance must be ionizes in water. When it ionizes in water, then it produces hydrogen ion. When they produces the hydrogen ion, then only we can classify that as an acid. Okay. Now, as I told you just now, get yourself prepared with paper and a writing tool. So let's write an ionization equation for these three respective acids. So I give you about 1 minute or 2 minutes. Can you try to do the ionization equation? How to write the ionization equation? Remember, class? Now let's look at the first molecule of the acid here, which is nitric acid. When nitric acid molecules dissolves and ionizes in water, what are the ions they produce? Write their respective ions and balance up the equation. Okay, I think I've done it. Now, this is the ionization equation for nitric acid. Now, when you look at nitric acid, the formula of nitric acid is HNO3. When it ionizes in water, it will produces two different types of ions, which is hydrogen ion and nitric ions. Next, look at B, sulfuric acid. Now, the formula of sulfuric acid is H2SO form. When one molecules of H2SO form, when one molecule of sulfuric acid dissolve in water and ionizes in water, they will ionizes 2 mole of hydrogen ions and 1 mole of sulfate ions. Why? As you can see in sulfuric acid, it consists of 2 atoms of hydrogen, right? So, in one molecule contains 2 atoms of hydrogen, and when it ionizes, it will produce 2 mole of hydrogen ion. That's going to be the balanced ionization equation for sulfuric acid. Third, H3PO4. H3PO4 is phosphoric acid. Now, when one molecule of phosphoric acid ionizes, please look carefully into the formula. The formula of phosphoric acid is H3PO4, right? In one molecule consists of how many hydrogen? 3, right? So, when it ionizes in water, it will produce 3 mole of hydrogen ion and phosphate ion. Now, as you can see in these 3 different acids, what is the difference that you can notice on the number of hydrogen ions here? Focus on the hydrogen ions produced. So, what we can say here, is it the number of hydrogen ions produced by all the type of acid are the same? No, right? Yes. So, the number of hydrogen ion ionizable in water depends on the number of hydrogen atom per molecule. And this is what we call it as basicity of acid. So let's look closer about basicity of acid. What's the meaning of basicity of acid, class, based on your previous activity? Can you derive the meaning of basicity of acid? So basicity of acid is the number of hydrogen ion produced by per molecule of an acid when it ionizes in water. And this basicity of acid, as how I show you just now, there are acid produces 1 hydrogen ion, there are acid produces 2 hydrogen ion, and so on, right? So based on the number of hydrogen ion they ionizes, we can classify them into 3 groups. So let's look at the first group, which is known as monoprotic acid. Okay, now what's the meaning of monoprotic acid? Now, example for monoprotic acid is nitric acid. As I explained to you just now, nitric acid, the formula is HNO3. In one molecule of this nitric acid consists of 1 hydrogen ion. Thus, when it ionizes in water, it produces only one hydrogen ion. Because it produces one hydrogen ion per molecule of the acid, hence we call it as monoprotic acid. Can you see the word mono? Mono is a kind of prefix for one. So remember, when it produces one hydrogen ion per molecule of the acid, then it's called as monoprotic acid. Okay, can you think about another type, another example for monoprotic acids? Beside nitric acid, there's another acid I explained to you just now. That is hydrochloric acid. So hydrochloric acid, nitric acid, and ethanoic acid are examples of monoprotic acid because they ionizes one hydrogen ion per molecule when they dissolve in water. Okay, secondly, diprotic acid. Okay, second group of the basicity of acid is diprotic acid. Now, what's the meaning of diprotic acid? Example here I've shown you sulfuric acid. Okay, sulfuric acid, the formula is H2SO4. Now, in one molecule of sulfuric acid, there are how many hydrogen atoms are there? 2, right? Can you see the 2 here? Hence, when it ionizes, it will ionizes into hydrogen ion and sulfate ion. And one molecule of sulfuric acid consists of 2 hydrogen atoms. Hence, it will ionizes 2 hydrogen ion. Thus, this acid basicity is known as diprotic acid. Third, H3PO4, that's for phosphoric acid. Phosphoric acid is an example of triprotic acid. Why? As you can see again, in one molecule of phosphoric acid, there are 3 hydrogen ions, right? When there are 3 hydrogen atoms in one molecule. When it ionizes in water, then only it produces 3 moles of hydrogen ions. Because it produces 3 moles of hydrogen ion, hence the basicity of this acid known as triprotic acid. So class, as you can see here among these 3 acids, we use monoprotic acid, diprotic acid, and triprotic acid. So the front name of it, mono, di, and tri is a kind of prefix. Mono means it's 1, di means it's 2, tri means it's 3. So you have to understand that when I want to classify the basicity of acid, it determined by the number of hydrogen ion ionizable per molecule. If it ionizes 1, monoprotic. If it ionizes 2, diprotic. If it ionizes 3, it's called triprotic acid. Okay. Next. Okay, I hope you have understand well about acid. Now I'm going to move on to alkali. What is alkali? For you to learn on alkali, first of all, you have to understand what is base. Now, as you can see here, one circle of base. Okay, what is base? Base is a chemical substance that react with acid to produce salt and water. And what are the type of base? What is the substance which called base? Okay, remember all metal oxide and metal hydroxide are base. Example, magnesium oxide, magnesium hydroxide, aluminium oxide, aluminium hydroxide, sodium oxide, sodium hydroxide, potassium oxide, potassium hydroxide. All these metal oxide and metal hydroxide are called base. So the definition of base is defined based on this metal oxide and metal hydroxide when they react with acid. If they can form salt and water, then we call them as a base. Okay, as you can see here, what I've done here is I'm very sure, I'm pretty sure that you have learned on this shape before. Can you recall where I've learned this? In your modern maths set. Okay, if I want to classify this based on your maths language, we can say that alkali is a subset of base. Okay, what's the meaning of alkali is a subset of base? And what is alkali? Alkali is all the base which are soluble in water. We call them as alkali. That means the base is the huge group of it. All the metal oxide and metal hydroxide, as long as they react with acid and form the salt and water, we call them as base. And among these bases, there are bases are soluble in water. There are bases which are insoluble in water. So those bases which are soluble in water, we call them as alkali. So the conclusion can be say, I hope you can respond in the chat for this question. I can see your responses here. Okay. Now, please let me know whether it's true or false. All bases are alkali. If I say all bases are alkali, is it true? Based on my explanation just now, you can see this diagram. Okay, base are metal oxide and metal hydroxide. And those metal oxide and metal hydroxide which can dissolve in water, we call them as alkali, right? Yes, if I say all bases are alkali, it's a false statement. Correct? Jeevan Prakash and Aina, I can see a response. Good. Deva, Pauline, excellent. So I hope you understand the term of alkali. And in return, if I say all alkali are base, is it correct? All alkali are base. This is the second statement I'm giving you. All alkali are base. True or false? Yes, good. So get yourself very clear about this. Don't have any confusion. So base is a huge scope. And among that, the small scope of it is alkali, which are soluble base are called as alkali. Okay. So now I'm going to move on to the definition of alkali. Okay, what is alkali? Based on Arrhenius theory, alkali is defined as a chemical substance that ionizes in water to produce hydroxide ions. As you can see in the diagram here, I've shown you, this is the this is the molecular structure for ammonia gas. When ammonia gas, by natural, it exists in a form of molecules. When ammonia gas dissolves in water, what happens is, actually this part you have learned in dative bond, covalent dative bond chapter 5. I just repeat back a little bit of it for you to recall back what you have learned in your chapter 5. When ammonia molecules dissolves in water, what will happen is it will form a dative covalent bond with the water molecules. Hence, it will result in the formation of ammonium ion. The formation of ammonium ion, the byproduct of it will be hydroxide ions. So during the formation of covalent dative bond between the ammonia and water molecules, there is a byproduct form which is called hydroxide ions. The moment the ammonia dissolves in water and produces hydroxide ions, hence we can say ammonia is alkali, because the definition of alkali is, remember the two keywords, Mass ionizes in water, alkali will produce hydroxide ions. Class, don't get confused with acid. Acid do ionizes in water, but it must produces hydrogen ion. If the substance produces hydrogen ion, then the substance is acid. But now, the substance ionizes in water and produces hydroxide ions. So when hydroxide ions are produced, hence we can classify the substance as alkaline. Now, as you can see in the yellow box here, this is the equation for the formation of ammonium ion and hydroxide ions, ionization equations. Now, ammonia molecules reacts with water. It produces ammonium ion, which is NH4 plus and OH negative. So due to the presence of hydroxide ions which have been ionized, hence we can call ammonia as an alkali. I show you the animation on this. Okay, as you can see here, this is the ammonia molecule and this is the water molecule. Let's look closely. When ammonia dissolves in water, see what happens. Did you notice that? When ammonia dissolves in water, I replay back. Okay. When ammonia molecules dissolve in water, the nitrogen atom will form a covalent dative bond with the hydrogen from the water molecules. Hence, it will result in the formation of hydroxide ions. Due to the ionizing of hydroxide ions, hence we call this substance as alkaline. Okay. So now, are you clear about what is acid, what is base, what is alkaline? So now let's do a short activity. Here I've given you about 9 substances. Please use I think, construct, classify this substance into acid and base. I give you about 3 to 4 minutes. Try to sort it them into acid and base before we learn further on their usage. Can anyone tell me from these 9 substances how many acids, how many bases are there? You can respond in the chat box. While doing your I think. Based on the type of substances I've given you, classify these substances into acid and bases. Use I think map to classify them. Okay, SN have given me the answer 5 acid and 4 base. Are you sure? Any more response, please? Pauline, 5 acid, 4 base. Okay, Adam Nitham, good. Nurul Amira, Aprilia, okay, excellent. So with this, I can ensure that you can identify acid and base based on their names, right? Okay, now can I continue? Let's look at uses of acids. And else, do you know that in our everyday life, we are actually handling about can't say thousands or millions, okay, at least about 5 to 6 different type of acid and alkalis we use in our daily life. Beside the name of the acids that I put here, can you give me another type of acid that you know that you are using it in your daily life? As you can see in my screen, here I've given the name of the acid with the usage. You can see the photo, right? From that, you know what's the usage for, okay? But besides this 5, do you think only 5 acid we have in our daily life? Of course not. There are few more. Okay, so let's look at the first acid, ascorbic acid. Okay, do you know what is ascorbic acid? Do you know vitamin C? Vitamin C is important for what? You need vitamin C, right? Okay, vitamin C is ascorbic acid. Another name for it is called citrus acid. And from where we can obtain this acid? We can get it from all citric fruit, like grapes, orange, lemon. All these fruits contains ascorbic acid. And what's the purpose of this ascorbic acid? Okay, this ascorbic acid is essential for our good health. And particularly right now with COVID-19, we have to have a good immune system. To boost up your immune system, you need more vitamin C. So consume more ascorbic acid. Secondly, carbonic acid. Okay, carbonic acid is used for in preparation of carbonated drinks. You know all sort of drinks which are favorable, I guess, right? Okay, so nowadays children, they like to drink soft drinks. Pepsi, Coca-Cola, 100 plus and all this. And do you know all this drink consists of carbonic acid? Third, ethanoic acid. Okay, you can see here teacher put up a picture of vinegar. So what is that vinegar to do with ethanoic acid? Okay, ethanoic acid, which is also called as acetic acid. And this acid is one of the content in vinegar. Next, benzoic acid. Benzoic acid is widely used in all sorts of food that we consume, especially in frozen food. What's the purpose of this benzoic acid? It acts as a preservative. Now, finally, we're going to look at sulfuric acid. This is the major acid which has been widely used in across all sectors. Okay, now the major function of sulfuric acid are, firstly, sulfuric acid is used to make detergents. You know the soap that you, not soap, detergent, detergent that you use to wash your clothes or even your dishes. That detergent is made up of sulfuric acid. Secondly, sulfuric acid is also used in manufacturing of paint. Sulfuric acid is one of the components in making of paint, and the wide usage of sulfuric acid is in production of fertilizers. You know what is fertilizers? Baja, yeah? Okay. Now we're going to look at uses of bases. So there are a lot also bases that we use in our daily life, but I just focus to the main one that you are familiar with. Okay. Now, is there any one of you start your day without taking bath? Do you agree with me that we start our day with base? You know why I say that? What the first thing you will do once you get up? Of course, you need to brush your teeth. You have to clean yourself. You have to take a shower. And of course, you're not going to take a shower with water alone, right? You have to use what? Soap. So, for your information, the toothpaste that you use to brush your teeth contains base which is known as magnesium hydroxide. And the soap that you use to take bath consists, that means made up of a base also, which is sodium hydroxide, or even there are also potassium soap you can use. So there are two types of bases used in preparation of soap, sodium hydroxide and potassium hydroxide. Okay, can you see it? So the function of base and acid are very essential in our life. We can't separate our life from these two chemicals. Okay, besides preparation of soap using sodium hydroxide, we also can use sodium hydroxide in preparation of detergent, bleaching agents, and fertilizers. Now, let's look at the second type of base. Okay, do you know what is antacid? Anyone have any idea about what is antacid? Okay, I'm pretty sure many of you will experience or have already experienced on gastric problem. When a person have a gastric pain, what they will consume? Usually when you go and see a doctor, what they will give you? You will see a bottle of white liquid. Am I right? This is called antacid. What's the function of this antacid? This antacid, which contains a base, which is called aluminium hydroxide, will go and neutralizes the excess acid in your stomach. That's how it's able to reduce the gastric pain. Now, the fourth type of base is ammonia. Ammonia is used for two main functions. First, in making of fertilizers. Secondly, is a raw material in preparing nitric acid. Okay. Now, any questions so far? If you have any questions, you can post it in the chat box. Yes, Jivan, your answer for antacid is correct. Medicine that neutralizes acid in the stomach. Okay. If you have no questions, then I move on to the next subtopics. So for information, so far we have learned on acid, what is acid, what is alkali, what is base, and their usage. So now we're going to move on to the role of water to show acidity. Why is water essential for the substance to show their properties, either the acidic properties or even alkaline properties? Okay, before we move on to the role of water to show acidity, can you all give me the properties of acid? You have learned about acid before in your lower secondary and also in your primary, am I right? Okay, can you post in the chat box the properties of acid that you know? The basic, the simple one, when I tell acid, what will come to your mind? Please respond. I can see there's 50 people are following the live classroom. Okay. Jeevan Prakash have responded, taste sour. Okay. Beside taste sour, Deva, corrosive, good. Nurul Nashba, you say that conduct electricity. Is it all the acid can conduct electricity in any state? Joanne, pH value more than 7. Acid, pH value more than 7. Jingwen, pH value lower than 7. Okay, now which one is which? Which one is the correct one? Ravindran have given me the pH value is supposed to be 1 to 6. Are you sure 1 to 6? Shushmita said conduct electricity when dissolved in water. Okay, good. So I can see some response from this chat group. It shows that you can follow my lessons. There's a positive sign. Good. Okay, class, let me correct your misunderstandings. Before we move on to the role of water to show acidity, let's reflect back on the basic properties of the acid. Acid, sour taste. The taste is sourish. Example, one of it is lemon. You know the taste of lemon? Lemon contains acid. So the taste sour. And the concentrated and even dilute there are, based on the strength of the acid, they are corrosive. Okay. And let's look at the third point, the pH value. I found here three different type of answer from the students. Some have stated more than 7, less than 7, and some have given me 1 to 6 the pH value, and the other one have given me 0 to 6. I hope by the end of this session, all your misunderstandings will be cleared. Okay, so as you can see here, the pH value of acid is less than 7. When I say less than 7, then what is the scale, teacher? You'll be asking, right? Be patient. In a while, I will show you. Okay. Now, when the pH value is less than 7, the chemical test, when you test it with a litmus paper, it will be responding to a blue litmus paper. The blue litmus paper will turn to red. When you see the blue litmus paper turns to red, then you will acknowledge that substance as a acid. Okay, just now we looked at the basic properties of acid. Now let's look at alkaline. So how about alkaline? The basic properties of alkaline: first, tastes bitter and feels slippery. Example, the best example for this is your soap. Just now I told you, base and alkaline are used to make the soap. So soap is slippery, right? That is one property of alkaline. Secondly, the concentrated alkalis are corrosive. The pH value for alkali are more than 7. So just now, Joanne, are you clear now? Just now you told me pH value more than 7 is acid. Actually, it's wrong. pH value more than 7 is alkaline. Okay, the others, all your response so far so good and correct. Okay, now the litmus paper. Which litmus paper responds positively to the alkaline? Red litmus paper. When you put red litmus paper inside the chemical, which is alkaline, so it will changes the red litmus paper into blue. When this happens, then we can acknowledge that as alkaline. Now, we're going to do a short investigation using solid oxalic acid and solid sodium hydroxide to study the role of water in showing their acidic and alkaline properties. Okay, during this investigation, what we will do is, you take a beaker. So let's say I explained to you here about sodium hydroxide. You take a solid sodium hydroxide, you put into a beaker. You can see my diagram here. Okay, you place it in a beaker, then you test with dry, blue and red litmus paper. You know why it must be dry? Because we want to study the role of water. So we don't use moist, we use dry. Yeah? Make sure there's no water at all. Then when you immerse the blue and red litmus paper, then you observe and record what you observe. And then what you do, you add little bit of water into it, stir it, make it to become a solution. And then now you immerse back, you test it back with the dry blue and red litmus paper. Observe and record. So are you clear? The first part, we do it with dry condition. We test the red and blue litmus paper. The second part, we dissolve the substance with water. Then we test it again with litmus paper, blue and red. Let's look at the observation. Okay, when I test with dry solid sodium hydroxide, what I observe, can you see it in the diagram? The red litmus paper remains unchanged. But after I dissolve it with water, what happens? The red litmus paper turns blue. What is this shows? The first condition, there's absence of water. When there's absence of water, sodium hydroxide is alkaline. So sodium hydroxide unable to exhibit its alkaline properties. But when after it dissolves in water, what happens, class? The red litmus paper turns blue. When the red litmus paper turns blue, it shows it able to exhibit its alkaline properties. Now, how about solid oxalic acid? The dry solid oxalic acid doesn't change any color of the blue litmus paper. That means if I say acid, just now only I told you, it must be able to change blue litmus paper into red. But when I test with dry condition in the absence of water, it doesn't show any changes to the blue litmus paper. But after I dissolve it in water, what happens? The blue litmus paper turns into red. So from this, what can we conclude? For an acid or even an alkali, to show their acidic or even alkaline properties, they do need water. Without water, they are unable to exhibit their acidic or even alkaline properties. Okay, why? Why acid or alkali needs water? Let's look at this diagram here. Acids, okay, there are two conditions. Acids, we call it as in the absence of water. That means the acid does not have water. Which condition is that? When you see the word dry or glacial. Okay, glacial means it's a pure acid. When the acid is pure, there's no water in it. Hence, this acid will exist in a form of molecules. The particles of acid will be in a form of molecules only. When they are in the form of molecules only, hence there's no hydrogen ion there, thus they are unable to show their acidic properties. Whereas when they dissolve in water, what will happen? As just now I explained to you, the molecule ionizes, they will form their respective ions, and one of the ion they will form is hydrogen ions. The moment there's a hydrogen ion, hence the substance able to show their acidic properties. And the same story goes for alkaline. Even alkaline, if they are pure and in a dry state, example in solid state, they aren't able to show their alkaline properties. They only can show the alkaline properties after they dissolve and ionizes hydroxide ions. Because only in water, class, remember, acid and alkaline, they only can ionizes in water. If you put them in other solutions, okay, what other solution we can use beside water? Any idea? Beside water, what are the solutions we can use to dissolve a substance? Okay, example, beside water, we also have other chemicals we can use as a solvent, and these solvents are known as organic solvents. Example, propanol, methylbenzene, and trichloromethane. These are the three famous or most popular organic solvents. So when you put them in this type of solvents, even acid or alkali, they cannot ionize their respective hydrogen ions or even hydroxide ions. The moment they cannot ionize, they cannot produce their hydrogen ion or hydroxide ions respectively. Hence, they are unable to exhibit their acidic or alkaline properties. Okay, now let's look at this question. Respond in the chat box, class. Okay, now here we have hydrogen chloride had been dissolved in two different solutions. One is solution X, another one is solution Y. Okay, and we are testing the solutions. That means after the hydrogen chloride dissolved inside the respective solution, we're testing it with dry blue litmus paper, and we also do another test on the electrical conductivity. Now, based on this table, the data we obtained, can you tell me the name of the suitable solvent for solution X and solution Y? Please write X is what, Y is what. If you just answer me propanon, I'm not sure which one are you answering me. Is it for X or Y? Please be specified in your answers. Tiaga Maler. X is what? Y is what? Please respond, class. Over here there are 48. I hope to get your response fast. Okay, thank you. Deva, solution X, water. Solution Y, organic solvent. Okay. Aprilia, X is water, Y is propanol. Now, here we have two different answers. As you can refer to the chat box, the students have given for X is water. Okay, Y X is water. As you can see, it turns the blue litmus paper red. And we have understand that if the hydrogen chloride want to show its acidic property, it needs water. That means the solution X must be water. And in water, because they forms the ions, they have the free moving ions, they're able to conduct electricity. So I think solution X is not a problem for you all. All of you, I think mostly got it right. Yes, good. Now, how about solution Y? My concern here, there are students have given me the answer organic solvent, and there are some of you have given me the answer propanol. Now, which is the correct answer for this question? Look carefully into the question, class. Based on the observation, name a suitable solvent. When they say name, you have to give the exact name of the solvent. You cannot say organic solvent. Okay, organic solvent is the type of the solvent. I mean, organic solvent is the general name of it, organic solvent. So you have to give a specific name of the organic solvents. So, as I told you just now, the most popular, famous organic solvent that we can use is propanol, methylbenzene, or trichloromethane. So, Kayong and Adam, are you clear now? So why you cannot write organic solvent? But your idea is that's good. So you understand that solution Y is cannot be the water, it must be some other solvent. The solvent is organic solvent, right? But because the question say name a suitable solvent, then you have to give a specific name of the solvent. Got it? Okay. Now I'm going to move on to the strength of acid and bases. Okay, for the strength of acid and bases, we can know the strength of the acid and base based on the pH value. Okay, just now some of you have given me acid means the pH value must be 1 to 7 and so on, right? Now let's look at this pH scale. Can you see it clearly? pH scales start from value 0 to 14 class. Is not starting from 1. So all the pH value you can determine, you will get at the range from 0 to 14. And pH 7 is neutral. Any pH value that you obtain less than 7 indicates the substance is acidic. Okay, whereas for pH value more than 7, the substance are alkaline. And how we can interpret the substance strength based on the pH value. Now, just now I told you that pH value, any pH value which is less than 7, consider acid ready, right? Okay, let's say I have two type of acid now. Acid A, pH value is 2. Acid B, the pH value is 0.2. One is 2, one is 0.2. So this pH value gives you any information about it? Is there any differences between this acid? There is, right? Okay, so the lower the pH value, the acidity increases. That means the acid become more stronger. The strength increases. And same goes for alkaline. As the pH value increases, the strength of alkaline increases. The higher the pH value, then the alkaline become more stronger. Now, based on the strength of acid and base, we can classify the acid and base into two categories of each. First, strong acid. What's the meaning of strong acid? Strong acid means it ionizes completely in water and produces high concentration of hydrogen ion. Examples of strong acids are hydrochloric acid, nitric acid, and sulfuric acid. Okay, now let's look at strong acid. The keyword ionizes completely and produces high concentration of hydrogen ion. Now, as you compare to your general definition of acid, we know that as long as it ionizes hydrogen ion, is acid, right? But what's the difference between strong to weak? The degree of ionization. Okay, the degree of ionization or degree of dissociation. Now, when the acid ionizes completely, then when it ionizes completely, how about the number of hydrogen ion it produces? Will be more, right? So it will produce high concentration of hydrogen ion. As you can see in this diagram, hydrogen chloride dissolves in water. Can you see? All the molecules had been ionized completely into hydrogen ion and chloride ions. This is called complete ionization. There's none of the hydrogen retained to be in the molecule form. Everything had been ionized to hydrogen ion. This is called complete ionization. When complete ionization takes place, then we call it as strong. Okay. At the same time, when complete ionization takes place, then the concentration of hydrogen ion they produce will be higher. So the definition for strong acid, you have to remember three keywords. Ionizes completely, produces high concentration of hydrogen ion. Okay. Whereas for weak acid, acid that ionizes partially in water to produce low concentration of hydrogen ion. Okay, what's the meaning now about ionizes partially? Please look at this diagram. You can see the ethanoic acid in water. Now, when ethanoic acid dissolves in water, can you see they are still remains in a form of molecules. Only some of the molecules can ionize into hydrogen ions, and some of it still remains in a form of molecules. This is called partial ionization. Okay, so when ionizes partially, the number of hydrogen ion they produce will be low. So that's why for weak acid, the definition we give is ionizes partially in water to produce low concentration of hydrogen ion. And when you write the equation, we will write two-way arrows because this reaction is reversible. So that's for acid. Now for alkali, we are running short of time, right? Sir? Excuse me. Okay. So because we are running short of time, I try to do it fast. Since you already understand about strong acid and weak acid, so I think it shouldn't be a problem for you to understand the strong alkali and weak alkali. The concept is the same. As long as it's strong, it ionizes completely. When it ionizes completely, it will produce high concentration. If it's acid, it will produce high concentration of hydrogen ion. If it's alkali, then it will produce hydroxide ions. For weak alkali, same thing, ionizes partially, concentration will be low. What ion is that? Hydroxide ions. So weak alkali is the substance that ionizes partially in water and produce low concentration of hydroxide ions. And we have to use two ways arrow because it's reversible. Okay, because we are running short of time, I think we don't have time to do our Kahoot. So that's all for today. Thank you, class. And I would like to get some response from y'all in my Padlet regarding our teaching and learning online today. Thank you.
Okey, terima kasih pada Cikgu Komathy atas kelas tadi. Saya telah pun letakkan link Padlet di ruangan chat. Sila klik link tersebut dan isilah give your response student pada untuk sesi kali ini. Okey, sekali lagi Edidik Negeri Perak mengucapkan terima kasih kepada Teacher Komathy dan insyaAllah kita akan aturkan untuk sesi seterusnya, kelas seterusnya dengan tajuk yang lain pula. Dan terima kasih juga kepada murid yang mengikuti siaran ini dan boleh terus tonton secara ulangan di YouTube dan jangan lupa untuk subscribe channel YouTube Edidik Malaysia untuk dapatkan perkongsian yang lain lagi selepas ini. Jadi sekadar itu, terima kasih semua. Kita jumpa lagi pada sesi yang akan datang.
Okay, bye.